Okay, and now we're going to give the welcome to our speaker, Daniel Fernandez. He's been a member of us for a long time. Daniel is a seasoned product manager leader with over 13 years of experience driving innovation in data analytics and machine learning products, particularly within the cybersecurity space. Known for his ability to bridge technical and business teams, Dan has led the development of solutions that deliver real impact across a range of industries. And also, I just want to add from things that I know, because Daniel is actually been a member of our community for a long time. And he has started community groups. He has a podcast. I don't know how he does so many things. And he's also an amazing speaker. So I just wanted to say thank you for being here. And the floor is all yours. Thank you.
Well, thank you for the kind words. Hi, everyone. So I'm Dan. So today I figure that, let me just make sure this is recording. Yes, okay. So there's a lot of talk about building security, building AI applications. So my goal today is, it's a very broad space. There's a lot of things happening in the space. I'm going to basically start with an introduction about what are machine learning applications, what are different components, and why is it important to kind of secure each of those components in the machine learning pipeline. Eventually going to get to generative AI and other areas, but this is meant to be an introduction for all skill levels. And if you have any questions along the way, feel free to interrupt. Yeah, we can make this a engaging discussion and interactive. So thank you for the amazing introduction. So I'll skip through this slide pretty quick. Basically, I'm a product manager. And in my free time, I also do like part-time teaching at Georgia Tech's online master's cybersecurity program. I'll share again like my contact details if you want to reach out. Standard, these are not my employer's opinions slide. And then also wanted to highlight that in this presentation, which I'll be sharing, there's a number of resources, which are denoted with different things. I think they're at the bottom of the slide. There's a few hyperlinks to some sample, very rudimentary code, sample applications, and other things that you may find interesting if you're trying to get started in learning more about machine learning development or machine learning security. Great. So as I said, we're probably going to start with an introduction to machine learning applications. And I'll use the word machine learning a lot more than AI. I'm not a big fan of that word because it's being overloaded and everything is now AI to the point that nothing is AI. So I don't even know what AI is anymore. So I'm going to be referring to it as mostly machine learning. And I wanted to do like a quick overview, like demystify like what to me are the differences between artificial intelligence, machine learning, deep learning, and data science. So the way I used to like to describe artificial intelligence is that you have like a fully functioning system, can have inputs and outputs, and is replacing an entire workflow, which I think some of the agents that exist today are a bit closer to that. But realistically, a lot of the applications that are in the wild in production today are machine learning applications, not really whether it's unsupervised or supervised machine learning. So unsupervised means that you're looking at unstructured data and you're trying to make sense of that data through different algorithms. And supervised is you have a target outcome that you're trying to potentially predict a risk score for someone that is using a credit card, or you may be trying to predict that someone is going through opening an account with malicious information. So what exactly more concrete, like I started giving examples, but I wanted to give some more concrete examples. So in a supervised machine learning model, I have here the example of like a house price. So if you look at Zillow, the website that has a bunch of listings online, you may see that they have a price component, and it kind of shows you like historical pricing data. And it also gives you like an expected value for that house. Yes, go ahead. Yeah, just briefly. Yeah, most of it is going to be on the security side, but if you have any specific questions, happy to go further into that. So if you have, like I said, a house listing, you may have like a zip code, address, other parameters that may be going to your predictive model on the price. Could be like the square footage of the house. Does it have how many bathrooms? Does it have a pool, et cetera, et cetera? And you use that data to model a future price for the house based on other inputs. So that would be like a supervised machine learning application that is in production. And classification, one of the best examples to give is that of like email. Classification could also be a unsupervised machine learning task. In this case, when you have an email filter, you kind of have, again, characteristics of what makes a email not malicious and malicious. And you use labels in your data set and things like the sender, the email domain that the email is coming from, and you're able to make a prediction. But you could also have like an unsupervised machine learning to your question. In that case, you can, let's say, have a bunch of customer records in your application, and you're trying to understand which of those customers look more like the ones that are profitable to you, the ones that purchase more from your services. That would be another example of a unsupervised machine learning. So customer segmentation, and then also there's a lot of like recommender systems, and these have been replaced a little bit by some of the generative AI tools that are kind of like already like indexing all this data, aggregating it, and creating some specific recommendations on the content that you may want to see. Now, like I said, the bulk of the presentation here is going to focus around machine learning security. And why? Well, there's a lot of real critical, whether it's like critical infrastructure or very important things that are using these machine learning applications and systems. For example, finance, public safety, and in cybersecurity. So in finance, if you are using one of those automated trading bots where, like, I think Wealthfront is one of those where you say, just put a fixed amount of money and it kind of like trades on your behalf. You probably want that machine learning algorithm to not be attacked by a malicious actor that is going to manipulate the market. For public safety, when you go through TSA, you have all the scanners that are kind of like classifying those images and putting rectangles around your body for people to check on you. Like, you probably don't want a foreign actor to be able to reverse engineer and understand how those classification models work and prevent one of those machines from catching something that they shouldn't, right? And lastly, in cybersecurity, a number of cybersecurity vendors are now using machine learning in order to prioritize alerts more effectively, et cetera. So some examples where this has gone wrong. So in finance, there was the flash crash that happened 3 or 4 years ago. Basically, someone was able to post from a social media account that some event had happened. There are automated trading algorithms from hedge funds and a number of financial institutions that trade on sentiment data from social media. So they were able to literally crash the market because someone was able to hack one account and manipulate the outcome of those trading systems. So again, why is that important? Not only does it affect the financial markets, it also can affect like highly sensitive systems that are using these applications. There are some examples also about disabling physical security. I think a lot of progress has been made around this, but when you have autonomous vehicles, self-driving cars, there used to be classification models that would kind of like look at everything surrounding the vehicle, whether there's a pedestrian passing by or a car at a dangerous speed or something like that. At some point earlier, like I said, this has been addressed, but an example of that is that you could put a specific set of pixels on a stop sign, and it would trick the model into thinking or ignoring that stop sign, potentially. So that would cause the autonomous vehicle to just keep going and potentially cause an accident. And then I think there's a lot more happening in terms of synthetic content being generated and how that can be used to manipulate public opinion and other areas. So that's another reason why it's important to secure the systems for society's sake. And then I wanted to provide an example around cybersecurity, because this is the area that I focus on most. This was, again, a couple of years ago. Anybody familiar with the website called VirusTotal by chance? Some of you are. So there's a website called VirusTotal that basically allows you to upload any file that you have, and it tells you whether or not it's malicious. It essentially has all the security engines from top security companies around the world, and they, for free, kind of like scan that file and let you know, is this malicious or not. It turns out that all of those engines are building machine learning applications that are finding that malware. And they are feeding their training models. So they're using training data from that same website to train their models. There was a threat actor that was able to upload a large number of bogus files. Those bogus files ended up getting trained in the classification model of those security products, which led to them being able to bypass those security products because they had manipulated the data that was going into the training of that model. So that is another example where data poisoning could be affecting the effectiveness of a machine learning model, which in cybersecurity would be very problematic. All right, so any questions so far? Yes. There is a repo that is linked here, and there's a reference to like a model scanning. So I'm looking at it from the angle of how to secure the machine learning models. But if you want, I can send you a few resources. But basically, yeah, there's a repo that is referenced in the presentation that you can go see a few example models that are using logistic regression and a few other things that are not generative AI. I can share with you if you want. Great. So understanding the machine learning supply chain. So in order to secure something, obviously you have to understand all the components that are in there. It's like the primary thing in security is like you first inventory where there's endpoints, computers, servers that you have in your organization, and then you try to understand how to make them more secure. So this is a great diagram from a gentleman called Deepak Bardawi that reached out on LinkedIn to share with you here. It kind of gives you like the overview of all the different components in a machine learning pipeline. I'll try to, it might be a little small in the back, but the essence here is that you have the data that is going into either training the model or the model running. You have the model development pipeline, which is a lot like software development pipeline. So to build a model, you need to import software libraries, potentially like Python libraries to be able to run your model. And then you have the actual system where this model is being executed. And this is just a long way to say there's a lot, this looks a lot like traditional application security, except that there's a lot more components here that also need to be taken into account when you're securing a machine learning application. So we'll start with the data. The reason to do that is, like I said, in the example I gave about the malware, like you need data to train your model. If someone is able to manipulate that data that is going into the model, that is going to affect the ultimate results of your training run. There is a lot of open source data, but that data comes at a risk. It's kind of like everything else. If it's free out there, there might not be anyone kind of like validating it. So there's a website called Hugging Face. I don't know if you're familiar with it, that has data sets, models to your question, if you want to see like out of the box models to play around with. But the challenge with using this open data sets is that you don't know what's coming. So any good basic hygiene is like if you're using a public data set to train your model, you've got to really understand what's going in.
For anyone who doesn't want to spend a lot of money, memory serves, you can sign up for that for free, use the spaces. And I think if you want to go to the paid spaces, I think it's like $100 a month, which will allow you to play with censored and uncensored models. And it's over it's almost 1.8 million models. Play with that now.
Yep.
As a side note.
Yep. So if you don't want to like set up a development environment in your local machine, you can use one of their workspaces, and I'll let you do up to a certain degree. If you start using like really data intensive operations and stuff, obviously someone has to pay for the hardware, and they're going to charge you. But if you're trying to get started and learn more about it, you should be able to use it for free, like Ron said. Thank you, Ron. So this is our first example. I wanted to make some practical, since it's a coders meetup, I'll do my best here to walk you through some examples. So this is going to be a high level like data poisoning example. So what we're doing here is that, so this is Google Colab, so similar to Hugging Face Spaces. This is like a development environment. If you want to run a Jupyter notebook and run Python code, you can do it for free with your Google account. So what I'm trying to do here is first just like importing some libraries. So what I'm going to be doing is loading this sequence of numbers. These are going to be my features into a variable. And I'm going to hash that data to be able to understand whether or not that data was manipulated in any way along the training pipeline. So here, pretty straightforward, import hashlib, which I'm going to be using for hashing. I'm importing pandas, which is a library in Python that allows me to manipulate data. And also going to import this string IO library as well. So what's happening here at the bottom, again, I'm just saying, I'm assigning original data CSV, the values in this table. We have an ID, feature 1, feature 2, and target. Target would be the prediction that we're focusing on. I know this is very simplistic, but otherwise it'll take a long time to go over this. So what I'm doing here is I'm loading that data into that variable, and then I'm using, I'm encoding that in UTF-8 here, and then I'm hashing that data to get a data hash. Again, the example here, what I'm trying to illustrate is the potential of someone manipulating your data that is going into your training model. So what we're going to do now is that we're going to manipulate that data. We're going to try to get a new hash. And what should happen is that if the data was manipulated, we're going to get a different hash, right? So here we have a simulation that we're now retrieving. Instead of using local data, we're retrieving data from a remote place. Probably like a database that you're using to train your model. And then we're doing the same thing and generating a hash for that data. And then here, excuse me, what we're doing is that we're importing the malicious data set. We're running the hashes again. And then we see that it's tampered because the hash for the original table that we had is different from the other one. Does that make sense? I know it's pretty simplistic, but it's just to like quickly illustrate this concept of data poisoning. Any questions so far? Great. All right, so we'll go back. Now we talked about the data. Data is going into the model. That's how we train our model. Now let's talk about the models themselves. So just like the data is coming from potentially random places, or you may not have control over what data is going into the model that you're using for training, you may also be sourcing models from Hugging Face or wherever. And that's great, but just like we have a malicious threat actor uploading bad samples to VirusTotal, we may have malicious models being uploaded to a public repo like this that could do some harm. And we'll talk a little bit about that in a specific example. So the main thing here is that when you're building a model too, you're not only like writing your own code, you're bringing libraries, right? You may be using PyTorch to build your model. You may be using Keras or something else. Now, everything that, just like in any other part of software development, if you're bringing a new library, you need to make sure that there are no vulnerabilities in that library to avoid your whole pipeline getting poisoned, right? So there's a lot of research on prototyping environments like Jupyter Notebooks, what we just saw to do the data example. And it's possible to even affect those Jupyter Notebooks with malicious code as well. So let's just jump, since I cover already like the open source models. Again, you can go to Hugging Face, you can go to, what's the other one? Starts with a K, I'm blanking out. I'll post it later. Yeah, Hugging Face is basically kind of the de facto model distribution and data set distribution mechanism. So, I mean, if it's not in Hugging Face, it's probably not out there. Okay, so now I'm going to talk. So I talk a little bit about like the security problems with models importing libraries, kind of like brush that off a little bit. And I'm going to talk a little bit more about potential malicious code that can go into the model that you're downloading. So to do that, I'm going to quickly talk about serialization. So basically, if you have the model in binary data format, when you're loading that model into your application, you're deserializing that data. It is possible in specific formats of data like pickle files to embed malicious code that when you deserialize that data, runs arbitrary commands on the host that you're using. And what you could do with that is kind of like remote code execution, where you could take over the machine that is running that model if you put a model with bad data or bad code in it, for lack of a better word. So the attacker in this case will craft a malicious payload. It would be hidden in that binary data file of the model. And when you load that compromised model, it's executing arbitrary code on your machine. So I'll quickly go through an example of what that looks like. Nope, I keep forgetting I have these open here. Okay, so Jupyter Notebook, again, we're installing one tool here that is called Model Scan from a company called Protect AI that helps you run through all the code that exists inside of your model to try to identify potentially malicious things. I did this in advance because I didn't know how the network connectivity was going to be. So pardon that the outputs are already here, just also to move a little faster because some of these are going to take a little longer. So here we're installing that tool called Model Scan. We're also installing XGBoost, which is going to be used for the example model that we're using here. And it's basically a diabetes classification model. And we're using scikit-learn, which is another machine learning library. Here in the import statement, we see that we're importing Pickle. That's what I mentioned, that is used for loading the model file into the application. NumPy, which is a computation library in Python, and a few other things. We'll skip through that. But basically, here we have our model. The model is kind of already stored in the file system. We're just like loading that model into our application here. And we are loading that as a Pickle file. That's the extension here. Now, if we see that we run our known good model, we see that the model predicts some value, again, making this like very, very straightforward. But here you're basically classifying, does this person have diabetes, yes or no, based on their A1C levels, information about their weight, and all that kind of stuff. Now, we scan the known safe model. That's what we're doing here. Again, I'll share the code here with anyone that wants to play with it afterwards. And we see that there's no issues found. But let's go down to like, what could be a malicious model serialization attack? So as I mentioned, what you're doing in this type of attack is that you're trying to obfuscate the activity that you're doing. In this case, we're trying to read the AWS secrets from the person's account that is trying to run this model. So you are injecting a command into basically the terminal as it's getting loaded and saying, as you load the model, do the system command and try to find any secrets that you can find in this particular folder. And that's the unsafe part of the model, right? So if we skip here now to running model scan, so here we're running that tool that I said, model scan, some flag that we're passing for the type of scan that we're doing, we see that we find a issue inside of that model that is critical. And it tells us here that the issue is that it's using an unsafe operator system, and that is basically running and extracting data from, where is it? Here. Sorry, I skipped too far. Here we're basically seeing that it's printing the fake AWS secret. So if you see here, when the model runs, you still get the prediction here, right? But you're also exposing the secret, in this case, an AWS key that is in the application itself. Any questions?
I know the next slide.
Yeah, so there have been a number of these exploits where there's like a lot of models that had, this is basically a vulnerability with the Pickle file format where there's no input validation when it's loading. Like theoretically, if you're loading a model file, you shouldn't have to be loading like this type of commands, or there should be a way so that when the Pickle file is being loaded, you're not injecting arbitrary commands into. So that there's been a number of these models that are out there in the wild that are SPICO files, and they have this security issues. Cool. So now we get to the part where we have our data. It can be tampered with. We have our model. It can be tampered with. And now we get to the point that we have to deploy that application into something. So ideally, traditionally, you would like host your machine learning application in a server of some sort. But these days, a lot of folks use containers. Has anybody heard about the Docker containers before? Has anyone not heard about Docker containers before? Cool. So just quick overview. It's like a better way to package your application so that it's easier to take from your development environment to your production environment.
Basically, that's models.
Right. Yeah. So you would store in that Docker container the machine learning library, the model. In some cases, the model itself. Sometimes you have the model by itself, and you have the container with the machine learning library, and then you load the model. And sometimes everything is packaged. But again, going back to like supply chain security for machine learning applications, the more that is pre-packaged for you and that is done for you, the less that you can trust it, right? Because you don't know exactly how that was done. So quick walkthrough here. You have your model, you have your app, you create a Docker file that is gonna say, I'm using this operating system, I'm using Python, I'm using some database, I'm running my machine learning library and running my model, and I'm packaging that into a container. Great, right? Except that there could be potentially vulnerable libraries and vulnerable software in that container too. How does that happen? So again, you could be loading a malicious Python software library. You could be loading a known bad version of a database technology. Basically, any software that is going into your application should have ideally low or zero vulnerabilities. So I'll show you a live example of what this looks like in the wild today. And there's like specific containers that have this vulnerability. So if we go to DigitalOcean, I really like DigitalOcean. It's kind of really easy to use. I'm not a developer, I'm a product manager, like I said. So it's a lot easier to use than AWS. So for this kind of thing, I find it a lot more straightforward. So I'm gonna do something. I'm doing a lot of stuff here that you shouldn't do, like have a container with like your root credentials and not changing it and not using SSH keys to log in. But again, it's a demo. But I'm opening the console here for the container that I have. I think this is quite small, so hopefully we can. Is that good? Okay, so what do we have here? We have Docker installed. We have a few Docker images that I downloaded in advance in case the network was not, one of them is like 1 gig, so that would have taken a while. So we have this is a little, maybe too big. There we go. All right, so we have the standard Python image that if you go to Docker Hub right now and you search for Python, this is the standard official community image that was built at the time that I saw it. It was built like a few days ago, and this is from 8 days ago. And then I downloaded an image from a company called ChainGuard, and what they do is provide zero vulnerability containers to just compare the two. And there's a number of other ways to do this. Potentially, if you're trying to build these yourself, you could try to build your own Docker image with the right version of software that is not vulnerable. So what I'll do now is that I'll run this tool called Gripe. It's an open source container scanner. And I'm going to run Gripe on both of these images. I'm first going to run it, and it's going to take a little bit longer on this official Python image. And what it's doing now is that basically it's loading that image in memory, is going to look for, if you see at the bottom there, it's kind of like syncing the vulnerability database, like all the known vulnerabilities are getting synced to my local scanner here. It's going to start going through all the files inside of that container and try to find libraries, files, anything that it can find. And then if any of those things match a vulnerability in the database that the scanner has, it's going to dump a bunch of vulnerabilities found in this container. So this is going to take hopefully not too long. If not, I think I have a screenshot of it because I figure that could happen. No, I don't. Okay, let's give it a little bit more time. Any questions so far while this loads? Yes.
So unrelated to this, Jupyter notebooks versus Python scripts, I haven't quite made the jump to Jupyter notebooks. What's the benefit of Jupyter notebooks? Is it just, well, why?
Yeah, I mean, I would say it behaves a lot like an IDE. You kind of like have the output in there. It really started like as a way to like document your code, where you have like all your code chunks, documentation, code chunks, documentation. You could see the output immediately of all the things that you're running. So I would say it's really more, I mean, there will be some people using Jupyter notebooks to run a production application. That's possible. You can have a Jupyter notebook, like a Jupyter server, and kind of like run your applications that way. But I would say it's mostly like a development tool for having a very descriptive way to look at the code that you're creating and things like that. Does that make sense?
Yeah.
But if you have an IDE, then you don't really need it. It used to be like also a way to share. It was like where you have notebooks inside of Jupyter Notebook server too, and it would like collaborate. But if you're doing Git-based like source control, then you kind of have that already. So it's just like another format, I guess, to store and explore the data. Okay, so that took a while because it's basically going through that 1 gigabyte of data, finding all the things that are inside. So far it's telling us that it's found 1,425 executables, and still counting, but roughly 400 packages. Okay, it looks like it's done. Now it's comparing to that vulnerability database. And now it should give us a count of like how many known vulnerabilities exist in that container that we just downloaded from Docker Hub. I should have upgraded the memory on this thing before the thing, but it's a very cheap and slow machine here. Sorry about that. All right, so they're starting to get aggregated here. So at the bottom here is giving us the number of critical, high, and medium vulnerabilities that is determined by the CVE. The CVE is basically an identifier for those vulnerabilities that are found. And there used to be a way, and here's listing basically every vulnerability that was found in that Python container that a lot of people are probably using. Well, you get the point. There's a bunch of them. A lot of them are low, maybe not exploitable. Some of them are high, like these that you see here. And there is one critical I saw somewhere. I wish these were sorted. There's probably a command I can use to sort that, but you get the point. There's a lot of bad stuff in there, right? All right. Now, if I do the same on a safer, more secure image, I go to, I can't remember the exact name of this one, so I'm just going to do Docker images again. And then I'm going to do gripe on this ChainGuard Python image. This should be a lot faster because if you notice, the other image was like 1 gigabyte. This one is 59 megabytes because it only has the stuff that you need. So this should go a lot faster, maybe.
In the right database, it's already gathered.
Right, it's already synced, so that should hopefully be a little faster. If not, hopefully you trust me that there you go. Okay, so that's fast enough. All right, so now it's trying to match all the vulnerabilities that are found. First thing, you see the other one had 400 packages. This one has 23. So the surface area of that container is a lot smaller. And you see here, ooh, some new stuff here. Okay, so when I ran this, it had 0. So we could try to, let's see, Docker.
Why don't you look up the critical CD online in the database, see what it is. The one.
That is a good idea. All right, so I downloaded the latest image. Let's see, because these get updated every day, and I haven't seen.
That way they understand what a CD is.
Right, so if I go to the critical, there's 2 of them. and I go to, I'm just going to Google that. It'll give me some data. So we go to the NIST database, the NBD, National Vulnerability Database. This is a government sponsor body, but there's a lot of private sector companies too that contribute to this. This could be a rant and we can get in all sorts of sidetrack, but this did not get funded. Before the current administration, this is not properly funded. So for a while now, the details about vulnerabilities that are being found in the wild are not really getting validated, which means that there's a lot of potential vulnerabilities there that we don't know how critical they are because no one has gone through the pain to verify, is this exploitable? How easy is it to exploit? There's just like a huge backlog of vulnerabilities that are going to the National Vulnerability Database and nobody's looking at them, which is a bit scary, but hopefully positive thoughts. Great. So we looked at container security. So we cover the data, we cover the models, we cover the environment where we're going to run that model, which is the container. And as you saw, there can be security issues in each of these data poisoning, model with a malicious command, or a vulnerable container that makes your application vulnerable. Yes.
The alerts, kind of like open the box so that you get them when they're coming in every time you run the CPCI.
Yeah, for the container images? Yeah, so typically you would build like a pipeline in your continuous integration pipeline that would kind of like, when you build your application, you would scan it with Gripe, which is open source. So there's a bunch of commercial products out there too. And then at that point, hopefully you would say, hey, here are the vulnerabilities that were just found. And then hopefully there'll be some automated mechanism that will trigger a ticket in the security team, and someone in security will see, hey, there's a bunch of vulnerable stuff in your container. You should probably go remediate that. Right. Yeah.
More like an open source that we use. Snake kind of tools where you can create your pipeline, where it does is it scans and you can predefine how much is acceptable, not acceptable. Based upon that, you won't deploy your code into environment. It will stop right there. Okay, you gotta fix this. Without this, I can't go and deploy to anyone because there's an exploiter.
Yeah, and that would go down to the security controls of every organization. And just because there's a bunch of low and medium vulnerabilities on there doesn't mean that they're exploitable. To your earlier question, like, are these being? So every company obviously is going to have a guideline that says, hey, anything critical, we're not going to let it go through our CI/CD pipeline until that gets addressed. And obviously in some highly regulated environments, banks, healthcare companies, and a few others, like they're pretty stringent around those. Any other questions? Cool. All right, so we get to the really cool stuff, the LLMs. Yay, right? Maybe. I'm a bit cynical about. I'm an AI optimist, but I'm also very skeptical about how much we're saying can be done here. Okay, but that's not the point of the presentation. The point of the presentation is to, let's assume you're not doing any of these old school machine learning classification models, and you're building a new agentic AI application where you have some sort of agent, whether you're like self-hosting your inference, or you're using OpenAI API, or you're using your own server, and you're trying to build something on top of that where you have a prompt, like instructions for that model, and you tell it, you are a customer support chatbot, and reference these knowledge articles that are in my knowledge base. And if anyone comes and asks you a question about this, please filter your answers from what's in the knowledge base. And hopefully that helps your support team answer less obvious questions that this tool can do for you. So the typical, this is a very overly simplified architecture, and it's from Byte by Go, but basically you have a coding agent. You may have some trigger actions that are triggering. In this case, it could be a user going on the UI and saying, hey, I'm trying to find how to unsubscribe from your service or something like that. That agent will then either respond based on how it was trained, or it would go to a knowledge base or a database and try to find that response. And then it would yield the output back to the user and be like, this is how you unsubscribe. So, like I said, I like DigitalOcean. I was going to show you just like a quick overview of what their Gen AI platform looks like. This is huge. Oh, okay. Is that readable? Great. All right. So Ron, the previous meeting, explained how to do this hosting on your own environment if you have a home lab. Another way that you can go about this, I mean, so far since I spun this up, I spent about $1.58. And that's because I'm running like a huge OpenSearch cluster to index some of the data that I'm feeding into the LLM. But the way that these are set up is that you pay per token used, kind of like similar to OpenAI and all these things, meaning that you only pay based on the how much text you're putting in and how much text is giving out to you. And if you go to, I'll just show you how to create a new one. Here is where you have your prompt for your agent. And here's where you select the open source model that you want to run. Ideally, these are vetted and someone went through the scanning process. We all want to hope that. And then it gives you here like how much you pay. So it's saying that for Llama 3, 70 billion, which is like I believe the latest Llama open source model, that is the one with the most parameters, you pay 65 cents for every million tokens that go in and out of that agent, right? And then here you have configuring the knowledge base, and what I did for this demo specifically.
Max size.
And
They have
I believe 70 billion is the largest Llama model that they have. They also have Claude 3.7. Oh, okay. So yeah, the way that so if you're using Claude, for example, you would have to do it through your Claude account.
So it's going right to there.
Yeah. And OpenAI, same thing. Because those are not really open source, like yeah. All the other ones, they're like hosting themselves. Okay, so let's say you create a model. So what I did was for this demo, I went ahead, I created a few agents. I created one with DeepSeek, one with, why is this not, it's because it's too. All right, so one DeepSeek with guardrails just for Ron, and one DeepSeek without guardrails. And the other thing that I did here was that I created, like I said, the most expensive part of this setup is the knowledge base. Let me see if it shows me where that server is.
So they have excessive data sets you can use to add to the very.
Yes. So I'll show you right now. So let's say, oh, okay. Couldn't see it. Okay. So knowledge base is running, like I said, an OpenSearch cluster in the background for me. All I did was literally, hey, I want a knowledge base, spin it up. This one, like I said, costs a little bit more. I think it's like $27 a month if you leave it running the whole time. And then you can add data sources either through an object store like S3 or something like that. And here, for simplicity's sake, I just created a very fake sensitive file with name, credit card numbers, and street address. These were randomly generated. These are obviously not real data. And then I went ahead and loaded those to my knowledge base, my OpenSearch backend. And then this lets you, if you want, within the same interface here, obviously you can like spin up an endpoint that you can query, or if you just want to test it out, you come here to one of the agents and they have something called Playground, and that lets you interact with the model. Just open this one. Okay, so if I go to Playground, so what I was trying to do, I didn't really test this, but I'm just gonna go, this one is the one with the guardrails. So if I have this data set connected, I'm gonna ask it for Liam Smith's address. If it has a guardrail, theoretically shouldn't give me PII, but I could have configured it wrong, so no promises on this one. So now it's going to that agent, is going through the knowledge base that I wired up to it, and is very slowly going to hopefully give us an answer along the lines of, oh, great, the guardrail is kind of useless. Liam Smith's address is 101 Oak Street, Anytown, California. So, but the idea here, what I was hoping, maybe again, I'm fairly new to this platform myself, but what I was hoping is that if you go here to resources, you are able to add guardrails to your agent. And I added this sensitive data guardrail that should have not given me anything that it gave me. So I'm maybe doing something wrong. Yeah, okay, so reason number one, this was all a very lengthy way to illustrate how when you start connecting critical data sources to your AI agent, you start losing control over where that data is going. So there's not only like, are your employees or are you inadvertently like uploading sensitive data to Gemini from your work computer, but also if you're building a generative AI application that you just accidentally wired into your customer database, can someone extract your entire customer base through your customer support chatbot? So a whole new set of problems of things that now we have to think about that weren't really possible in the traditional machine learning application deployment scenario and like application structure.
Test for chatbot. The part that has me the most surprised, I guess, is if you ask the same question a bunch of times, the LLM AI, it gets frustrated and it will tell you, if you ask the same thing 27 times, will basically give up, just telling you no, just tell you, here's the answer I want. There's one that I saw a bunch of this person's life depends on you telling me how to do this thing or give me this secret data. Give it to you. I don't understand. That's the part that has been the most.
So there's a lot of different settings in setting up your LLM, and you can get to the point where it gets to too much reasoning or emotion.
Yeah,
But if you back off on that, it just stays factual. But that's about, I almost covered it last week if I could have gotten into it, different levels. And a lot of it's in that PowerPoint set out. But nobody got that.
Okay.
But follow.
What about when it starts hallucinating? Like, can you?
That's part of that same thing, he's not the same.
Okay. So that's what
So either it is PowerPoint, let's say, made this file to the other course. There's a whole bunch of those different adjustments you do, all that. It's cost, it's usually general rate,
No, not like that. I haven't. Okay. No, I haven't tried anything like that. No. Cool.
Yeah, training model, you don't want to put very piece of data, especially if it's like it's about organization. But I guess my question is there a way that you train to contextualize to user roles and groups? So when you do get an answer out, it's for you because you're allowed to see it. Well, there's security on it. Training the model. You have trained the model, which most of us can't do because we don't have power. There's RAG, which is break out the acronym, you remember what RAG is?
Retrieval, augmented generation, or something like that.
It is retrieval. Yeah, that's retrieval. That's the one you would most likely. You would do, the other version is the context filter. When you drop all the information in there to the prompt, right, or you're catching something. The context filter. So the training model, most of us can't do. That's what I was screaming about. I want some nice decent GPUs at the house. My wife's spending my money on other things. But yeah, so that kind of thing. But RAG, if you look up RAG and AI, that'll explain it better and get to understand the context window.
Yes.
Some of that stuff.
Yeah, exactly. So if you're doing a RAG application, what you would do is like you kind of like wired in all those data sets, assuming you're not necessarily like you said. So there's pre-training and post-training. So pre-training is what Ron's talking about, where you're like building the foundation model from scratch. You need like thousands and thousands of computers. And then there's like post-training or fine-tuning, where you're kind of like teaching the model things that are unique enough to your environment, to your corporation. Now, to your question, I'll answer your question twofold. Like, potentially what you could do is like do a rack style application, connect those data sets, and then as you're building the agent, you should say, when this, like authenticate your user up front and say, when this user is asking a question, your RAG could access data sets A, B, and C. If a different user is answering the question, your RAG should not reference those data sources, potentially, right?
Well, no, it can be a document too. So how many here have ChatGPT? Okay, so if you were to do ChatGPT, there's MyGPT. Okay, in there, when you start telling chat how you want it to be, to specialize in something, like the classic customer support machines that people they all use. Classic customer support, in there, you could do like 25 of data that we have on how we do customer support for people. You could go, but going more advanced than that, RAG, you could wire up Zendesk or some other thing with customer support. You could wire all that in, because in a Zendesk type situation, like they use at the university, you get all the notes, everybody was solving the problem and all that. So you can find similar tickets that had a problem. It would be in that database. That's RAG data, or the knowledge base. It's used by the LLM and how you instruct the LLM to work.
To your actual, I think the question is, if you have a large data set, and I query it through an AI process, I actually give back the data that I can get by which was read. There's a product called Glean that does that. So Jira, Confluence, Slack, will search all those things, but only give me data that I had extra back. No idea how to do it on the back end, right? Because individual Slack discussions and channels, it has those all indexed, and it knows if I'm asking to only give you the ones I have access to. So no idea how it does it, it's magic, but it actually works really well.
But we got those.
Great. So just to wrap it up, you can play with Gen AI platforms like DigitalOcean. There's a bunch of different options out there. Again, to me, this is fun because you can just put $5 in it. Once you run out of money, that's it. It can't go wild and spend $3,000 on a credit card kind of thing. But again, security problems here is like, you should have guardrails. You should protect how you're connecting it to your data stores internally, et cetera, et cetera. Great. So now let's talk about vibe coding. Has anybody heard about this before? Yeah, so that just means we are all professional software engineers that write amazing, perfect production code that is 100% secure, right? So vibe coding is basically this word that is used for using this AI coding agents that you can, don't get me wrong, as a product manager, I'm biased. Like I like the fact that I can have a random idea over the weekend, spend like 2 hours trying to put something together, and there is a functional prototype of something that should never see the light of day or become a production application, and I can like tangibly see that what I just built and use it, and that's great. But I think the problem is when you assume that because you can do that, you can now deploy that to the world and everything's going to be fine. There's a bunch of security issues with this, compromised dependencies. So when you're vibe coding, just like we said, like you're importing libraries, Python, runtimes, Python libraries, JavaScript libraries, whatever language you use. Now there's a predictive model in the backend that is deciding for you which version of software should be in your application, right? So if you don't know and you're not like verifying that this code that was just generated just imported a bunch of bad stuff, it's going to be there. And the more we outsource our thinking, the better it goes for the quality of the application, right? So compromised dependencies, insecure code, like just like you and I could write a bug, the AI is going to write bugs. I think we all get it, right? Like we all see the problem here. So of course, I was bored and I was thinking like, what is something like really, when I grew up, like, you know, when you had this like AOL disk and your internet was like really slow and you were on IRC because there was no Slack and you saw that like you were trying to torrent something and it was taking too long. Of course, you went to good old Battleship. So I was like, what if I can go on one of these applications and code my own Battleship app? Would that work? And this thing is on top. Here we go. So I went to Lovable, which is a lovely, pun intended, vibe coding tool, which was amazing. I mean, full disclosure, I spent less than an hour on this. It created this web app that is a Battleship game. I can create a new game. As you know, you have to select. And the best thing about this is like if you play with your siblings or your family members, you know that you're playing and they're moving the boats as you're telling them things and you can't really see. But with a computer, you can't move the boats once they're in place, right? So you go ahead and you put all your boats. And then I'll try to do something. It's probably not going to work, but I believe, does anyone have their computer open? You should be able to play now. I click ready to play, gives me a game ID, which is a little too long. Again, I spent an hour on this. It could have been like a shortened URL or something like that. I would drop it on Discord. All right, let me stop sharing to not. So they're recording. Oh no, Discord is having, is Discord having Cloudflare issues today? Let's see the web app. Okay, that's the code. The URL is here. And if the AI is a good programmer, we should be able to play a quick game of Battleship here. We'll see. I won't refresh because I learned that it doesn't keep your session. Sorry?
What are some of the prompts?
I literally, so I've gotten to the point where I'm using AI to prompt AI. So I said, write me a prompt to create a Battleship game. And then I use the prompt that the AI generated to throw it to the other AI to generate the app for me.
So it's the same model for the pre-prompt?
I use Gemini Pro for generating the prompt, and then I dump that into Lovable. And then the only thing, literally the only thing I had to do was create a Supabase account that is the backend for the game. And then it kind of like went spinning its wheels for like 25 minutes. I made a few adjustments and then there, Battleship, right? So obviously it's not as fun because you're seeing my screen, right? But look, I just try shooting one of them to see, so you see how it turns red and stuff. B3 is one of them. Oh, I hit one of yours. Look at that. Oh, I missed. So you get the point. 40 minutes. I just built Battleship. This is crazy. Like if you told me 5 years ago that I could build a Battleship game in an hour, crazy, right? But of course, there are some bad news. I loaded the code base to GitHub, and there's a bunch of depend-about alerts. Most of them are not that bad, but the AI kind of like just put the key of my Supabase, and it's still there, so I'm surprised nobody has found it yet. The key is in the code base, so someone could just, oh, is that someone take over my Supabase? No, that's Discord. Good. All right. So, but you get the point. So the other thing I did was, this is a nicer view of that. There's this tool called Aikido that is like application security scanner kind of thing. And I think it's a slightly more visually appealing. So here's the problem. It found my token for the database, which is a bit problematic. So long story short, these tools are great. They're a lot of fun, but we need to make sure that we verify the output before we put something in production. So that was that. Security issues. I also ran samgrep in case that web thing didn't work, but all good. I had an extra example here. So mitigation strategies. You should do supply chain security on your GenAI vibe-coded application as you would for everything else. You still look at the containers, you still look at the data, you still look at all the other things that we covered. And then I want to talk about a couple of other emerging trends. And this is a bit like more related to my most recent job that is around GPU security. So if you're not using one of these commercially hosted GenAI applications and you're hosting this thing yourself, let's say you work at a bank and you want to have a GenAI customer support bot that is going to have access to sensitive information, you may or may not want to use OpenAI API. You may want to host that agent yourself. If you want to do that, you're going to need GPUs. Long story short, GPUs are expensive. There's a number of them going out there. But one of the biggest critical challenges around securing GPUs is that even though we have a lot of runtime security for other workloads, so like if you spin up a server now on AWS, EC2 instance, there are a bunch of tools that give you visibility into like what's happening inside that EC2 instance, what's going in, what's going out. When you're talking about GPU workloads, by default, the architecture is that the GPU has access to the full memory of the entire, like when you give access to the GPU and you're running a workload, you have access to the entire memory, right? That memory doesn't get wiped. So if you're using like a shared GPU on a cloud and you don't wipe your memory after you're done with it, you could potentially leave your model weights, or you could leave your keys, or you could leave whatever is in your. Sorry?
Is that white versus unloading the model?
Right. And also you're not able to like manage these things effectively. So there's like I think like there was some stat out there, like 60% of GPUs that you're leasing are not being used because you don't have visibility until what's actually going in and out of the hardware. So there's a number of reasons there. I won't dwell too much, but just wanted to highlight that is kind of like a new, like once you're deploying your own workloads, you have to be cognizant that now you have to secure those GPUs. It's just like a bunch of new servers that have their own quirks and need to be secured themselves. And then the last thing I want to talk about is that MCP servers. Have anyone or everyone heard about them? Yeah, so it's kind of like an abstraction layer API of sorts so that all the agents can interact with data in a more predictable way. So to the gentleman's question earlier of like, how do I ensure that they're getting access to the right data? Potentially if you're using an MCP server to Atlassian or something like that, you could have like more granular controls of how the data is being queried, all that kind of stuff. But MCP servers also have a bunch of security challenges. You can have too much permissions in your MCP server, accessing things they shouldn't, indirect prompt injection, basically all kind of like all the same problems we just talked about, just like a new area of the stack that you have to be concerned about. So takeaways. I think, how are we doing on time? I think we have 5 minutes or yeah. All right. So we got the whole stack. We covered that. Basically, you got to secure everything. Just like a few things. when you're wiring your like Gen AI applications, make sure that if you're fine tuning, the data that's going in has high quality. If you are connecting to a database, make sure that it's not your CEO's emails are now being read by the entire company. Do input and output sanitation. So the guardrails are essentially protecting your company from you trying to manipulate the agent to give you data it shouldn't. So a guardrail in the input would be, do not allow this type of questions coming into the chatbot. And also on the way out, like once the answer has been generated, how do you ensure that data that you don't intend to go out doesn't go out, right? And some of the same things around data protection, encryption, minimize what's going in, like don't put data sets and records that shouldn't be, et cetera, et cetera. Then you have the layers to protect when you're building your application. So again, prevent loading the wrong dependencies in your application. If you're running in containers, secure your containers. I think most of these we have covered. And lastly, around authentication, which is going to be another whole, it's like, if you give access to a data store, how do you ensure that that agent only has access to the things that it should? So I don't want to dwell too much on this. That's it. Hopefully you found some of it useful. Any other questions?
So basically, this is kind of the same thing you would do OWASP rules for securing an application. You would do for this on a scale of data.
Exactly. Yeah.
Data input,
And there is an OWASP effort or initiative that is around LLMs only that has a bunch of, yeah, granular controls and recommendations and that kind of thing.
Your MCP, right? There was a one topic where you can run, like I have a model, I can like frustrating the model, right? So that could also potentially lead to the denial of services, like a data set, that kind of thing.
Right.
I was just reading. So can you elaborate a little bit? And maybe a quick example.
So
How do we avoid? I mean, I know we could make it easily, but how do we avoid those kind of things?
yeah, I think that would be more like depending on the levels of control that your MCP server has. Like if you have access to, like if your MCP servers allows you to run arbitrary code, you could load a script that says, ask yourself 1,000,000 questions a second, and that could have an issue, right? But it's really coming down to like, what can you run? Like what permissions do you have on the MCP server or on your chatbot agent? There's a lot of work. There's a company called Dagger that is just open source. An interesting way is like if you're running this chat agents, you're kind of running them inside a container by themselves so that you avoid doing that. So you cannot, like, a coding agent should not be able to escape itself from like its intended purpose. And there's a whole lot of area of research around that. It's like, how do you further isolate if you're having a code agent, like, because they're predictive models, they're, to your point earlier, they'll give you different answers. So if you ask the same question, please code me the Battleship app 25 different times, it's probably going to look very different every time you ask it. So sometimes you may want to do like a spin out like 100 coding agents. But if you have that, then you have the potential for DDoSing yourself, right? Depending on how you're protecting it. Does that answer your question? Or the what? Sorry. Have I haven't personally, no. So the question was, have you tried to find software and other things in the deep web with generative AI or with AI? No, I have not. Have you tried to like crawl the deep web with generative AI tools?
Well, like Hack GPT and Fraud GPT and those sites, they're out there. You can get them all.
Ron knows. Just ask him.
Another reason I'm not rails off of my own system and run that same.
Cool. That's all I have. Thank you.